Lou Chateliers. Okay, this is the French scientist. So French scientist, that's why this name is like Louis and Lou Chateliers principle. So what it says, the Lou Chatelier's principle talks about the undo change. Okay, what is the change? See, whenever the equilibrium is disturbed, then it tries to undo. That is the principle. Means you, let's take, you are sitting in the class, not classroom. You are sitting at home and you are doing some work. You are making some PPT or maybe some word file. You wrote so many things, and you just went for drinking water. And your small sibling comes, okay, brother, sister, and they are like doing something, and you come back and you see what you do first. You slap. Now, if you are good, what you'll do? You'll just do Control Z, right? Undo. So whenever equilibrium is disturbed, then reaction tries to undo the change. That is Lee Chatelier's principle. Write down. Whenever equilibrium is disturbed, whenever equilibrium is disturbed, reaction tries to undo the change. When equilibrium is disturbed, reaction try to undo the change. And equilibrium can be disturbed by changing. What all things we can do to disturb equilibrium? Temperature change, concentration change, volume change, pressure change, catalyst, and so on. So we can write equilibrium can be disturbed by changing concentration, pressure, volume, and temperature, etc. Temperature, etc. Equilibrium can be disturbed by changing. Equilibrium can be disturbed, okay? Can be disturbed by changing concentration, pressure, volume, okay, or temperature. So first we'll learn effect of changing concentration or simply effect of concentration change. Effect of concentration change. Equation, if we write, let's take N2 plus H2 gives ammonia. Okay, 3, 2. All are gaseous. N2 plus 3H2 plus ammonia. Okay, and this reaction is in equilibrium. Okay, so equilibrium N2, this is not T0, okay, this point is equilibrium point, and that's why N2, H2 and ammonia concentration is constant. Okay, if equilibrium is disturbed by changing concentration, so what we can do, we can change the concentration. So if N2 is increased or H2 is increased, then reaction tries to decrease the concentration. You understand? See, if you increase N2 or H2, then reaction tries to decrease. And if you want to decrease, then reaction goes forward direction. Clear? Is getting right? So when we increase the concentration of H2N2, reaction goes forward. Or if we decrease the concentration of ammonia, then it tries to increase, means reaction goes forward. If I increase the concentration of ammonia, then it will try to decrease, that means reverse, right? That means we can write to increase the production, of ammonia, production of ammonia, concentration of N2 and H2 is decreased and increased and ammonia is decreased, or ammonia is continuously removed, decreased, or we can say ammonia is continuously removed from the solution. So to increase the production of ammonia, concentration of H2 and N2 are increased, okay, and ammonia is decreased or removed, so that rate will be forward direction. This is theoretical understanding. Okay, let's study by graphical. So we changed, so we increase the concentration, and this becomes, if we increase the concentration of N2 here, this goes here, we increase at this point, and ammonia is decrease. So if you disturb, that tries to become like equilibrium is not changed, right? Or we say that initial concentration or equilibrium constant is independent of initial concentration. You increase, decrease, but the equilibrium remains same. So if you are increasing, then it will decrease slowly, this will decrease slowly, and this will increase, and again it will attain the equilibrium. So this point is not equilibrium, again there is the equilibrium. So what happened? N2 and H2 are consumed and NH3 is formed. That means forward reaction. Draw the graph. So first we understood this concept theoretically. Second, we understood this concept graphically. Third, we have to understand the same concept by using reaction quotient. Okay, this is clear? Write it 2 points. This is 1 point, this is second point. Okay. Third point is, means in that only third point, QC. So QC is equals to concentration of product by concentration of reactant. And if concentration of reactant increases, then QC decreases. And here QC becomes less than KC. So what is the rate? What is the direction? Forward direction. Clear? You understood this by using 3 points. What will be the change in concentration and how to increase the production? So reactants are increased, the concentration of reactant is increased and concentration of product decreased, or product is continuously removed from, as soon as it prepares, as soon as it is formed, we remove that to get more. Okay, clear? Is everyone clear? Okay, next, effect of what is the second effect of change in effect of pressure change? Again the same question. N2 plus H2 gives ammonia. 2, 3. Okay. If we increase the pressure, if we increase, all are gases, okay? Gas, gas, gas. If we increase the pressure, volume is decreased. What is the law? Huh? Okay. Okay, no problem. That is Boyle's law. Okay. Boyle's law talk about P, V constant. So P increases, volume decreases. And concentration is equals to number of moles by volume. So in short, P increases, volume decreases, molarity increases. That means by this we understand that pressure increases, molarity increases, or we can say concentration. It will be more clear. Pressure increases, concentration increases. So reaction tries to, pressure increases, concentration increases. So reaction tries to decrease the concentration. So if you have to decrease the concentration, then what has to be done? Volume more, but volume is already decreased. Number of moles should be decreased. Okay, so what we can write? Pressure increases, concentration increases. So to decrease the concentration, number of moles has to be decreased. And that's why pressure increases and equilibrium shifts to that direction. When pressure increases, write down, when pressure increases, equilibrium shifts to that direction where the number of moles of gases are less. So here if you want to increase the production of ammonia, then pressure has to be increased or decreased. Increase or decrease? Really? If we increase pressure, then equilibrium shifts to that direction where the number of moles of gases are less. So where the number of moles of gas is less? Product side. And that's why by increasing pressure, reaction shifts to forward direction. Clear? Is it clear, everyone? Yes? Okay. Okay. Third. What is the third point? Yeah, effect of volume change. Or sometimes it is said by adding inert substance. By adding, means equilibrium is disturbed by adding inert material. Yes. So effect of volume change means by adding inert material or by adding inert gas. So what will happen if inert gas is added? Okay, then volume is increased. So volume increases, concentration decreases. It tries to increase the concentration. So what has to be done? Increase the number of moles. So write down. Write yourself. What your point is written before, you have to make some modifications in that point and write down this point here. Yes, Vivek. Sorry, Vinay. Vinay. विवेक मतलब क्या रहता है? इंटेलिजेंस, आई थिंक। या विनय मतलब ह्यूमिलिटी। क्या क्या नाम है बारी बारी बोलो बेटा। डेफिनेशन, not definition. What you wrote just now, you read that.
I didn't write and just copy down.
Arey. Yes, Deva. No, Yes, what did you write, Amana? Volume? No. By adding inert material, volume should increase, right? See, if we are adding inert material, then volume increases. So we have to write when volume is increased or when we add inert material or inert gas in the mixture, when we add inert material or inert gas in the mixture, then reaction shifts to that direction where the number of moles are more. Okay. Equilibrium shifts to that direction. Okay, not reaction, equilibrium shifts to that direction where the number of moles are more. Clear? Is everyone clear with these two things? Pressure and volume. You understood, you could relate that with concentration, right? And we already studied about the concentration thing. We already studied about the concentration. Yeah. Then fourth, catalyst. Temperature. Okay. Effect of temperature change. Effect of temperature change. See, equilibrium constant is independent of so many things. Like it is independent of pressure, it is independent of volume, it is independent of concentration, but depends upon temperature. Right? That we have written. If you are not written, write down. Okay, Kc depends upon yes, Kc is independent of pressure, concentration. Okay, and volume, but depends upon temperature. So what happens? So if the reaction is exothermic, then if temperature increases, Kc decreases. And in endothermic reaction, temperature increases, Kc increases. This is about Kc and this is about Kc. But what about the forward and backward reaction? Okay, how the equilibrium shifts. Okay, so that the same thing happens. First, we'll learn for exothermic reaction. Exothermic reaction. So, what is exothermic reaction? Hey, when heat is released, like N2 plus H2 gives ammonia, and here delta H is minus 92 kilojoule per mole. That means this is exothermic reaction, and this heat is released minus 92. So if heat is released, that means temperature will increase, but heat is released, right? Yes, if heat is released, then temperature of that reaction or mixture will go down or increase. Increase. Okay. So how it happens? Basically, heat is liberated. So reaction happens and heat is evolved, and that's why this solution or the reaction mixture becomes hot. That is the reason. Okay. Now reaction becomes like it. Let's just take an example. Okay. Reaction is performed at 100 degrees Celsius and it reaches to 150. Okay. And what we are doing, we are And also, when you reverse this reaction, then this becomes positive, right? That means you have a reaction A to B. You have a reaction A is converted to B, reverse also. And this is, let's take, when it is taken, then temperature changes from 100 to 150. Okay. And if B is converted to A, that means temperature will change from 150 to 100 because it is endothermic reaction. This is clear? Next. In this case, when A is converted to B, A is getting converted to B, and that time you are increasing the temperature. Increasing means you are taking it to 200. So reaction tries to decrease. So how the temperature will be decreased? When the reaction goes reverse. Making sense? Getting? Right? That means if you want to increase the rate, okay, if you want to increase the rate of this, then you decrease the temperature. So if you are decreasing, it is 100 degrees Celsius, it is going to 150, but you are making it cool. So it is not reaching 150, it is 130, 120. So again, it will try to make it 150. So production is going on. And that's why in exothermic reaction, temperature is decreased to increase the production. Write down. In exothermic, okay, in this reaction, temperature is decreased to increase the product. But the problem is we can't make it zero, or we can't like decrease it to very low temperature, because at low temperature the reactants will not get the enough energy of activation. That's why we need optimum temperature. So in this reaction, optimum temperature is needed. Optimum temperature. Not like we decrease. We have to take, we can decrease this, but we have to take optimum temperature. Below that, if you take, then reaction will not occur. Or reaction will occur, but rate will be decreased instead of increasing. So optimum temperature is taken in this type of reactions. Exothermic, clear? Everyone is clear about exothermic? Okay, next, endothermic. Endothermic reaction. Endothermic. So endothermic reaction means it needs temperature, right? It needs temperature. So if we are giving temperature, then it will be happy, right? So it is taking temperature. So rate will be forward. So write down here, temperature increases to increase the rate of the reaction. Temperature is increased to increase the rate of forward reaction, forward direction, or to increase the production of product. Temperature is increased to increase the rate of forward reaction. Clear? Is everyone clear? Any doubt? No doubt, sure? Okay, and the last point, fifth, right? Effect of catalyst. What is the effect of catalyst? Yes, it only decreases the time to reach the equilibrium. And whether it increases forward direction or backward? Yes, doesn't matter, but how it increases, okay. Whether it increases forward or backward direction?
Both of them
yes.
Equally.
It increases both forward and backward. Okay. A catalyst increases both forward and reverse reaction. Catalyst increases both forward and reverse or backward reactions. That means what happens? Yeah, equilibrium is attained earlier, or it takes less time to attain the equilibrium, or equilibrium is attained fast. You can write anything of this. Equilibrium is attained earlier. Clear? Okay, why this happens? Okay, then what it does? Yeah, so it reduces the activation energy. See, so many points we studied in chemical kinetics. Same thing we have to write here. So if you have studied, you remember that. It reduces the activation energy. Yes. What else it does? It provides the different path for the reaction to proceed. Okay, it provides the different path for the reaction to proceed. Okay, different path for the reaction, so that the reaction can be very fast, right? If there is like a big mountain, okay, and to go this we have to go by only one way like this, and then if you make from this there is a route like this, then it is like easier to go, right? So this is a different path. Okay, this happened in Oman, like 25 kilometers you have to go to reach one place, one place, yeah, one village, and there one village, or maybe a small place, we can say a town, and they just made the route like this, so that 7 kilometers only. So this is like a different path provided. Okay, catalyst is clear now? Any doubt in the catalyst? No, right? So these 4 points you should know for any reaction. So we'll just take 2-3 questions and then we'll stop. So you have to tell all the 4 changes. Okay, 4 you have to tell. Question number 1: if it is N2 plus O2 gives 2NO, and here minus 40,000 or 40 kilojoule, minus 40 kilojoule. First of all, what is minus 40 kilojoule here? Heat is released or required? Required. If it is plus 40, that means that much heat is released. If it is minus, the minus goes here and becomes plus. That much heat is required. Yes, write down all the changes. You have to write like 1, concentration; 2nd, the temperature or pressure; 3rd, volume; and 4th, like that. And just write down decrease, increase, like that, to increase the production of NO. To increase the production of NO. Yes. Concentration, pressure, volume, and temperature. Yes, in concentration, what has to be done? Huh? Yeah, increase the N2 and O2. Increase the concentration, and NO remove or decrease. What about pressure? Huh? So no effect. Pressure has no effect over this reaction. Volume or adding inert material. Yes. Volume or adding inert material, any effect? No effect. And temperature? Temperature? Huh? Increase. Okay.